Right.
Can we generalize to other cultures, other communities within this culture?
Yeah. Well, we're limited with Framingham. Remember, Framingham has been used to make all kinds of conclusions about the benefits of aspirin, the risks of high cholesterol, and the like, and we accept those findings. And what I'm interested in, I see myself as a basic social scientist. So I see myself as someone who's trying to understand something very fundamental about our humanity. And therefore, I feel that I'm somewhat more insulated from concerns about generalizability in the same way that someone who studies a group of rats and finds something or other, we don't say to him, well, you know, it's just in these rats. If you had looked at these other rats, you wouldn't necessarily find it. Now, the analogy is forced. I agree. It is forced. But, and there's no doubt that Framingham is an unusual population. But to be honest, ours is the only such data set that exists. I mean, it would be very hard. We've begun to think about some others, like using the Facebook network. We're beginning to sort of try to reproduce some of our results using Facebook. But that's shorter time periods, you know.
If you were to speculate, what would be the cultural?
I wouldn't. I don't.
That would worry you about the external validity, or gee, no, they seem to be.
No, I would. If anything, I would. My supposition would be that these ideas of interpersonal influence and these notions of spread of norms and behaviors and notions of clustering and homophily are very fundamental. I would expect to find those pretty much everywhere I looked, frankly.
You would statistically be hardwired.
Yeah. In fact, we believe, and we're doing some other work with James Fowler and I, looking at the genetic origins of some of these network behaviors. But I need to rush to assure you that I'm not an essentialist in the sense that I think that all social behavior is genetic. It's not, by any stretch of the imagination. But I do think there's something very fundamental, you know, on a par with the law of supply and demand or the incest taboo or whatever. I mean, we don't think the incest taboo is there's not a gene that prohibits you from an incestuous relationship, but we think there's something very fundamental social about this. And I think a lot of the processes we've been discussing today are like that, are very fundamental. Yeah, of course. There's no doubt. Yes, that it creates fitness. But yeah, that's correct. But the question is, how is that? Do we actually think there's a gene inside you, a specific gene that somehow lets you identify? You know, we think the HLA stuff. Yes, that's right. You pick your partners based on HLA incompatibility. Yeah, yeah. How about cannibalism then? Do we think there's a gene that prohibits cannibalism? Or the law of supply and demand? Do we think that there's utility maximization? Yeah. I don't know. Yeah, I don't know. But I can't, this was so much effort to build this data set that I can't imagine trying to do it all again. We're doing other data sets. AdHealth, of course, is the famous one now that's publicly available, and that we're replicating some of our results there. And the Facebook network. Yeah. Yes.
Where do they do that? Are there courses?
So, it's very cutting edge. It's hard. I mean, for instance, there's a course at Harvard at the graduate level that's taught by Peter Marsden that teaches network methods. There are substantive courses from time to time in different departments around the city. There's some summer courses that are offered by Stan Wasserman at Indiana and Bernice Pescosolido that you go for a week or 2 weeks and learn about the topics and about the methods. There's software that you can get, but there's software that does a lot of the graphics that I've shown you. This was done with a package called Sonia, which is freeware, and there's the other graphics were done with a package called Pajek, which you can download as well, and you can buy a book and read how to draw the pictures and stuff and compute some of the things. But the statistical estimation, there are some packages, UCNet, UCINet, StatNet, and the like, and there are courses, but there's not like at the undergraduate or graduate level a whole lot of them yet. It's kind of specialized still. And a lot of the stuff is still being invented as we speak, a lot of the statistical and inferential methods.
So it's the kind of thing where you really have to get this stuff in a network to some extent.
Yes. Yeah, and we have a network of networkers at my lab. I mean, we have a bunch of us that are doing this stuff, and my grad students work with each other, and we kind of bring each other along. I'm learning all the time from the people in my group. I mean, there's so much that's happening, and you just can't keep up with the innovation right now. I think what Juliet was talking about earlier is true. I mean, and I'm often asked, do I think sort of network science is a fad? I mean, there are fads in academia and in science. There's no doubt. But I think that there is something different about the 21st century. I mean, I think we had a very reductionistic period in science where the idea was that we could understand the whole by looking at the parts, and even the geneticists are beginning to realize that, soon we're going to know all 22,000 genes. And then what? We have to put them all back together somehow. We have to realize how those components fit together to lead to embryogenesis, to lead to the kinds of physiologic properties we see. Is it something to do with networks of genes? How do we get consciousness from neurons? Is it something to do with the networks of neurons? How do we understand all these emergent properties? How do we understand networks of computers, networks of people, and the like? And I think that across many branches of science, there's an increasing interest in putting all the parts together and understanding the fundamental rules. And this is being led in large measure by a lot of physicists. I mean, it's actually quite interesting. The intellectual history here is very interesting. If you'll give me 1 minute, I'll tell you a story. The study of networks was almost exclusively the study of social networks for 100 years. So beginning with Simmel at the end of the 19th century, up until about the 1970s, borrowing some ideas from some Hungarian mathematicians in the 1950s especially, what scientists who studied networks studied were networks of people. And these people were struggling in the wilderness. They didn't have data sets. They didn't have mathematical techniques. There wasn't the computational power to study these kinds of things. And they kind of reached the limit in the 1970s. Mark Granovetter's famous paper on the strength of weak ties and the like. And then what happened is, beginning in the 1990s, all these physicists started moving in and borrowed all these ideas from sociologists. It's one of the very few circumstances where you can see physicists and molecular biologists respectively citing sociologists, like citing basic papers on how you compute centrality, how you figure out what the ties are between nodes, how you render these images, and so forth, because they were interested in networks of genes or networks of computers and networks of other things. But they perfected the science very rapidly. I mean, the mathematics just exploded, and the statistics exploded in the last 15 years. And all that armamentarium is now coming back to the social sciences. And what we're seeing is sociologists and other social scientists exploiting now these new methods, as we do, to try to take it to the next level in understanding sociological phenomena and social scientific phenomena. And so, it's a very active area methodologically and otherwise to understand these things. Yeah, students, yes, you.
I'm really curious to hear how you'd like to see your findings be implemented sort of on the ground level. Like how you want people to spread the word about this sort of social obligation that you were talking about the spread of all these epidemics, if you will.
Well, I mean, I have more limited aspirations than changing the world. And I think that some of the stuff that we're looking at can have the kind of clinical implications I was asked about earlier, in the sense that we can realize that, first of all, that a lot of our treatments of different kinds of social clinical problems or social phenomena are more effective than we realized. So if I spend $10 to get you to quit smoking, but your quitting causes each of 10 of your friends to have a probability of 0.1 to quit, so an extra one person, and each of them has a probability of 0.1 to cause each of their people to quit. And if I fold that network back, I might see that getting you to quit smoking, spending $100 on you, is actually I'm getting 10 people to quit. So my intervention is 10 times more cost effective than I previously realized. So that's a big policy implication, a generic one. And the idea that I argued about earlier, that intervening on groups, do I have grander aspirations than that? No. That is to say, I don't imagine that there are ways that these ideas could be affirmatively exploited to improve the world, but they can in big ways. But there are lots of applications in little ways. So we can think about, for instance, trying to cultivate a diffusion of desirable knowledge within networks of doctors. So if we're trying to get doctors to do the right thing, we might try to use these ideas to try to get them the information to spread, or between nurses, in a more rapid or reliable way. And if we can do that, then we can improve patient care and so improve humanity on that ground. I mean, some people have asked me on the happiness thing, do I think there's a kind of, and we're looking at this, we're looking at the spread of altruism, James Fowler and I, and like a pay it forward kind of way. If I'm nice to you, do you go home and you're nice to someone else, and then they're nice to other people, and we can kind of improve society. I think that's true. Actually, I think that can happen.